Hello and welcome to Simplexplanations, a show that explores math and computer science topics in an approachable way. Today we are going to look at how computers look for things. The other day, my son Loki asked me what an algorithm was, so I decided to teach him about how computers search through lists. If you are a parent watching this video, I encourage you to try this out with your children, ask them the questions this video asks you, and see what they can come up with. The ultimate goal of a search algorithm is to either find a number or realize that it isn't there as quickly as possible. The faster that a computer can do this, the faster that the program can run, which for something like a video game means that you get a higher frame rate. What a computer does to search through a list isn't anything a human couldn't do, so we'll think about how we would search through lists. These lists could be made up of anything, but usually the computer ends up just searching for a number, so we'll search through numbers as well. When the numbers are all jumbled like this, there isn't a whole lot we can do if we're looking for a number. If we wanted to look for the number 5, we could start at the left side and look to the right until we found it and then stopped. If we wanted to look for the number 7, however, we'd have to look at all the numbers before we knew it wasn't there. If we sort the numbers, though, we can do some more interesting things. Once the numbers are sorted, if we want to look for the number 5, we can start at the left and go right until we find the number. This is the same as before. If we wanted to look for the number 7, though, we can stop as soon as we find a number larger than 7, instead of having to look at all of the numbers. This is better, but there is another clever trick you can do to search through a sorted list more quickly. Might want to pause the video and give it a think, see if you can figure out a better way. What if we look at the number in the middle of the list? If the middle number is less than the number we're looking for, we can throw away everything to the left. If the middle number is greater than the number we're looking for, we can throw everything to the right away. Once we throw away part of the list, we can just repeat this process. And once the middle number is the number we're looking for, or when we run out of numbers to look at, we know we're done. This is called a binary search. The first way we search through a list makes you look through all the numbers of the very worst case scenario. A binary search, on the other hand, has a worst case scenario of you only having to look through log base 2 of the numbers. That means if your list had 32 items in it, you would only have to look at 5 numbers at most, instead of all 32. And going even further with that, if your list had 65,000 items in it, using a binary search you'd only have to look at 16 numbers at most, instead of all 65,000. Binary search isn't the only way to search for a number in a sorted list, though. There's also something called an interpolation search, where if you know the minimum and maximum values in the list, you can use that to guess where your number might be inside of there. That search, the interpolation search, can actually be very fast, especially when you flip back and forth between doing a binary search step and an interpolation search step. I'll put a link in the video description if you want more information about that. And at worst, the interpolation search has to look through all items, but under ideal conditions, it's actually the log of the number of items in the list. So it can actually be pretty fast. You can also use hashing to look for numbers. Hashing works by putting a value through a hash function, which tells you an exact place to look at to see if the number's there or not. This can give you an answer in just looking at one number, but there's some details about why this isn't used all the time, having to do with things like memory allocations and hash collisions. Lastly, quantum computers can actually search an unsorted list by only looking at a square root of the number of numbers that there are. It does this using something called Grover's algorithm. It's outside of the scope of this video to explain how that works, but it is pretty cool and it's worth knowing about. With luck, we'll have quantum computers before too long to help us do things that they excel at versus regular computers. If you like this video, leave a comment and hit the subscribe button. If you have questions in the realm of math or computer science that you'd like to see simply explained, let me know. And see you next time.